We've learned in a previous video that dynamic routes are learned by routing protocols. And routing protocols are protocols that we configure on two adjacent routers so that they can share information with each other about what networks those routers are connected to. Now, there are basically two different big broad categories of these things. There are interior gateway and exterior gateway. Interior gateway tend to be limited to small groups of routers. Exterior gateway protocols tend to be larger and can span a large number of these interior gateway types of systems. So within interior gateway we have two types: distance vector and link state. So let's delve into these. First of all, the interior gateway protocols. We'll talk about distance vector, and the primary example of that is one called RIP, or Router Information Protocol. This tends to be used on smaller networks. There's a later version, RIP version 2, that is actually a little bit more useful today because RIP came out before we started subnetting very much. So it's not as used today as it has been in the past. But in the case of distance vector protocols, routers share information with each other about networks that they are connected to, and they give two pieces of information. One is how far, and the other is which direction or what port. That's the distance and the vector. So let's take this example. I'm going to move my face out of the way here. We had this network in our previous video where, let's say, a packet comes out of this PC and needs to go to the 30 network. Well, this router right here does not know anything about the 30 network. So if I have RIP on these two routers right here, this router, which is connected to the 30 network, will advertise to this router that it's one hop away. Yes, I can get there in one hop, and that it is on port A, because this router, of course, can see port A over here. And so it says, hey, port A, I can get there in one hop. This one would say, hey, 30, I can get there in 2 hops. 1, 2 hops. So in this case, A would choose this way to get there because that's the fastest way to get there. So the distance, how many hops, and the vector, which port, which direction to send it out of. This happens up to 15 routers deep, so these routers can learn their way around a pretty good number of networks. And then the lowest cost path is the one that has the least hops. So it's going to take the lowest cost, and it's going to come out of there and take the one hop route in order to get there. That's RIP. Link state protocols, which are also interior gateway routing protocols. The primary example is one called OSPF, or Open Shortest Path First. Now, in this case, what happens is each router in this system will send information to its neighbors about the quality of the links. Now, it will tell it what network, and it'll also tell it the quality of the link. Now, the receiving router, let's say that this router 1 over here is the receiving router, and router 4 was the one that sent the information. Well, router 1 over here will do its own calculation and say, okay, let me see, if I want to get to this network over here off of 5, it takes me a cost of 20 plus a cost of 10 to get there this way. It takes me 20 plus 10 to get there this way. It takes me 5 plus 10 plus 10 to get there this way. That's 25. So look at this. It's going to go 5, 10, that's 15, 25. It'll take this route to get over there. Whereas if it will not take this route, because that will cost it 30. So this router, the receiving router, will draw its own map of the networks it knows about, and will figure out on its own the least cost path in order to get to where it's trying to go. There are some hybrid protocols that are kind of distance vector and kind of link state. I see I didn't capitalize the word distance there. EIGRP is one of those. So Enhanced Interior Gateway Routing Protocol. This kind of is a hybrid of the two. We're not going to go into the details of how it works. Now, exterior gateway protocols, there are more than one, but we're only going to look at one here in this case. Let me move my picture again there. In this case, what we're talking about are these protocols that can span more than one autonomous systems of these routers. Now, back here with EIGRP and OSPF, these guys here, you would set up an autonomous system, and they would advertise within that autonomous system. But now we can span across them, so that, for example, on the internet, and sure enough, BGP, or Border Gateway Protocol, what am I saying, is Border Gateway Protocol is the one that we use on the internet in order to get across the internet. So that's it for a quick overview of the routing protocols. Now, if you go on to a more advanced course, like the CIS 278, you will actually set up some of these routing protocols yourself and tell it how to advertise them and set up the autonomous systems and so forth in some hands-on labs there. But that's it for this one.